Welcome! In this series of videos, we will cover the design and implementation of a project, from initial design through coding and development to testing, using the PowerBasic Windows compiler. Today we will continue our project to create our own web browser by adding more functionality to tables. This was our application at the end of the last video. We have created a Lite browser, and we're currently in the process of adding table functionality. If we go to our HTML pages and we drag in an HTML page, we can see the details appearing in our browser. However, there are a couple of bugs that appeared after the last video's recording. If we have a look at the table at the bottom of this page, we can see it has two columns. However, the first column is not entirely fitting into the column space. I think this is likely because we're using bold for the column headers, and each bold character takes up slightly more horizontal space than an unbold character. So we'll need to tackle that in our code. If we add additional columns to our table, we can see another problem. We now have 4 columns in this table. However, the problem we have with this is there is no vertical dividing line between column 3 and column 4. So this is obviously a second bug. So we will fix these 2 bugs first of all, and after we have corrected those, we're going to add in another attribute for the table. One of the attributes you can have on tables is width. You can specify the width of a table in either pixels or as a percentage of the dialog. If you set the width to be 50%, then the width of the table will be half that of the browser itself. Alternatively, if you set the width to 800 pixels, then the width of your table will be exactly 800 pixels. So let's go and have a look at our code. So the first thing we're going to attempt to fix is our vertical lines. If we have a look in the display table function, and if we scroll down, we'll see at the bottom of that function is a section which draws vertical lines. The problem in here is it's drawing the first vertical line at the division between column 1 and column 2. For this logic, part of this is actually working. However, the vertical line starting position is always the beginning of the table plus the width of the current column. So this is always drawing the same vertical line. It needs to have an offset to know that it has already drawn the column 1, column 2 vertical line and is now to move on to column 2, column 3. So what we need in here is an offset value. For the first vertical line, the value of x offset will be 0. Therefore, it will perform as it does now. For the second iteration, for the next column boundary, we need to set that value. And we can do that down here by setting the offset value to be equal to the starting point of our vertical lines. So we'll need to declare this variable at the beginning of our function. So there is our variable declared. So if we try running our application now, and if we drag in our page, we should see we now have a vertical divider between column 3 and column 4. So our vertical lines are now working correctly. However, we still have to sort out the amount of space taken up by the column header, as it is obviously intruding in to the next column. So that's our next task. As the width of a character is worked out by the font we're using, and we're using a wider font for the column headers as it is bold, we'll need to adjust that when the table is drawn. So again, back to the code. So in order to get a little bit more control of a dialog, I'm going to change the way the dialog was created. When you create a dialog using the dialog new command, and do not specify whether you want to use dialog units or pixels, it will default to using dialog units. The use of dialog units allows PowerBasic itself to work out the best place to put things on screen. Most of the time, this works out fine. However, when you want a little bit more precision on where things are positioned on the dialog, you're better going for pixels. This does, of course, necessitate a little bit more code. So let's go to the place where we create our dialog. So on this line here, we are not specifying either dialog units or pixels. So we're going to amend this and use pixels. Plus, I'm going to make the dialog a little bit bigger. So we're now going for 850 by 550. And we're specifying the word pixels in the dialog new command. Plus, I'm also increasing the width and the height of our graphics control. Plus, while we're in tidying up in this particular function, there's a part in here where we set the size of the virtual graphics control. And we're putting a multiplier of 3 in here. Now, as this is a hard-coded value, I'd much prefer that this was in as a constant, so that we can set it at the beginning of our code, and that will take effect through the whole application. So that's exactly what we're going to do. We're going to put a width multiplier and a height multiplier. So we will add these two new constants at the beginning of our code. There is one other function which has also been hard-coded for this adjustment. That's the resize controls function. As you can see, this has this multiplier in place. So we'll just slot in these two new constants. So that's them both in place. Next, we will look at the width of table function. This section of code works out how wide each column is in our table. Our problem is that we have a different font, a bold font, for the headings of each of the columns, and these are slightly wider. The best approach would be to recalculate the values which we're going to be using here for the width. However, we're going to take a slightly simpler approach. In this nested for next loop, we're looking through each of the columns, and we're looking from the second row to the last row. So in this part, we're ignoring the first row completely. And the first row is the one that holds the headers. So we're going to amend this to look for the first row. And we can then test to see if we're doing the first row and act accordingly. So we're going to replace this section of text. So we will first of all test to see if we are on row 1. And we'll also test our header variable to see if this table has a header. If the table does not have a header, then there's no point in continuing. If it has a header, then we want to work out the value of our columns, and we're going to add on 2 spaces. This will add on 2 characters to the length of the text. This is a bit of a workaround, as it depends how many characters we have in each column. But for the moment, it will get us past this particular problem. So for this, we're going to be quite pragmatic. For all other columns, we'll leave the calculation as it was. The other thing we're going to have to do is we're depending on the value of this variable header. However, it is not one of the parameters coming in from the previous function. So we're going to have to add that. And of course, we're going to have to add that into anything that calls this function. And this function here, display table, already has it in its parameters list. Therefore, we merely have to pass that on to our called function. So if we try running our application now, and we drag in our HTML file, we should see we appear to have sorted out the detail of our titles. Our vertical lines are appearing correctly between each of the columns, and our column headers are not wandering into the next column. As I said, this is a pragmatic approach to our current issue. If we have a really long column title, this would probably still be a problem. However, for the moment, we'll move on to what we want to do next. We want to pick up a new attribute for the table. If we have a look at page 5 in a normal browser, we'll see on page 5 that we do have multiple tables, and the width of our first table is 50% of the width of our browser. So it is quite dynamic. The second table appears to be of fixed width, and this is obviously set for pixels. If we view the source for this particular page, we will see the first table has a width set to 50%, and the second table has a value set for 1200. If we drag this page into our browser, it would not pick up the width because we have not put any code in to handle the width attribute. So that is our next task. Back to the code. So if we have a look at the display table function, in the parameters list, we're passing table attributes to this function. So the details of the width will be held within this table attributes string. We merely have to interrogate it. So we're going to need a new variable to hold the table width amount, and we'll call that table width. This will either be a percentage or a size in pixels. Next, we need to populate this variable depending on what the user has actually put in. So we can do that by looking for the words width followed by the equals sign. So we can then populate the table width amount by using the parse command twice. First of all, using width equals as a delimiter, and then using the space as a delimiter. This will return either 1200 or 50 and the percentage sign. So now that we have this information, we'll need to pass it on to the width of the table function. So we'll need to add another parameter onto its parameters list. So there we now have the table width amount added on to the parameter list. So now, of course, we'll have to go to the width of the table function. And we'll add that parameter to its list of incoming parameters. So we have two options coming in this variable. We're either going to be fixed width or we're going to be scaled. We're going to have a percentage width. Therefore, we will create another variable which will be either true or false. True if the table is going to be scaled, i.e. percentage, and false if it is not. And there is our new variable. So next, before we get to the for next loop, we're going to have to pick up the value. If the table width amount is a 0-len string, then there is no set value for the width of the table, and it will be dynamic based on the data contained within it. So we can test this quite easily. If the value held in the variable is not an empty-len string, then the table is set for fixed width and is therefore scaled. If the value is an empty-len string, then we'll set this variable to false. We can then test the rightmost character of our variable. If that contains a percentage sign, then we know the total width is going to be a percentage of the width of our dialog. If that is not the case, then we will populate the total width variable, which is an existing variable, to be the value of what we find within the table width amount. For example, 1200 pixels. We're also going to have to call a new function here. Since we want the total width to be a percentage of our control size, we need to work out what our control size actually is. So we'll create a small function to perform that. This function is basically one line of code. I'm putting it into a function just in case in future we need to expand upon what this is going to do. But we can use the graphic command to work out the width in pixels of our size. As we have designated our control on the dialog as being done in pixels, it will return in pixels. If our dialog was still done in dialog units, this function would return dialog units. So now that we know the total width of our graphics control, we can now move on to the next part of the code, inside the for next loop. This steps through each column, and the existing code goes ahead and works out how wide the column needs to be if the table is to be dynamic and controlled by the data contained within the table cells. However, if this table is to be scaled, then we can test that and act accordingly. We can put a test in on the scaled variable. If that's the case, then the value held within our array of table columns is going to be equal to the total width divided by the number of columns. Otherwise, the table is going to be dynamic. So this simple test to see if we're having a scale table or a dynamic table can handle both scenarios. And at the end of this function, which returns the total width of the table, we'll need to do the same kind of test. We can test to see if the scale variable is false, and if that is the case, we can use our existing functionality. If this is true, then we will skip over this piece of code and return the pre-populated value of the total width of our table. So now that we have this code in place, will our browser behave correctly? Let's try running and see. There we have our browser. And if we bring up our pages, and we drag in page 5. Page 5 appears to be identical to what we had in our Chrome browser. The first table is half the width of our dialog, and the second table extends beyond the width of our current dialog. If we stretch our dialog, we will see that the second table remains at a fixed size. However, the first table remains at 50% of the width of our browser. If our browser becomes wider, so does the table. And the table below, which is fixed by the data within the table, does not change at all. So we bring in page 6 just to make sure that still works, and it stays at the existing size. And page 5, quite happily, is now fully scaled. So in summary, what we've achieved today is we have fixed a couple of bugs in the drawing of tables. We have sorted the vertical lines to ensure they appear correctly. Additionally, we have widened the columns to take account of the fact that the headers are slightly wider because their font is bold. And we have added new functionality to support the width attribute for tables, to allow our tables to be of a fixed width or a percentage width. Hopefully you'll find these functions useful in your own applications, but that's it for today. Thank you for watching.